This is asteroid Vesta, the second largest asteroid in the solar system. Vesta is quite special when compared to other asteroids. For one, it's one of the only asteroids that can be separated into crust, mantle, and core. And it's nearly large enough to be considered a dwarf planet. But for years, two geological features on the asteroid have puzzled scientists. Today, geologists have proposed a new theory for how these regions formed on the asteroid, and we're going to talk about it. But before we jump in, be sure to do the thing and like, comment, sign up for the mailing list, and subscribe. I'm Eric Malachite, author of the Seleniars Enigma series, and this is Science Get. Vesta was named after German mathematician Carl Friedrich Gauss by its discoverer Heinrich Wilhelm Olbers. Weighing in at 530 kilometers in diameter with a mass of 2.67 times 10 to the 20th power kilograms, along with a shape that is nearly spherical, all of this makes Vesta important to understanding the origins of our solar system. In 1996, Vesta made its closest approach to the Earth, about 1.14 AU from the Earth, which really isn't that close. But it's thanks to that close approach that the Hubble Space Telescope was able to map its surface, producing topographic maps of its surface features. This revealed a huge crater at the South Pole that slices into the asteroid's interior regions. The crater averages about 460 kilometers in diameter, which is seriously something considering the asteroid is only 530 kilometers across. This crater cuts deep into the asteroid at an average depth of 13 kilometers. The crater, known as Ray Silvia, is thought to have formed from an impact early in the asteroid's life. The asteroid also has a number of moons that orbit it that formed from the same impact. These are called Vestoids, which is just fun to say. Vesta's interior consists of cooled lava covering a rocky mantle and an iron and nickel core, which gives credence to the theory that it was a protoplanet at one time. Its core is thought to have accreted quite rapidly within the first 10 million years of its life. The basaltic crust is thought to have formed over the course of a few million years as well. NASA's Dawn mission estimated Vesta's core to be about 18% of the asteroid's total mass, making it about 2/3 as massive as our own core. We'll be talking about Dawn soon, so hold on to your butts. It might surprise you to learn that scientists think that if it weren't for Jupiter's presence, Vesta might have actually become a planet. Dawn scientist David O'Brien of the Planetary Science Institute of Tucson, Arizona says, in the asteroid belt, Jupiter basically stirred things up so much that they weren't able to easily accrete with one another. But two features discovered in 2011 and 2012 on the asteroid have been puzzling scientists, making them question Vesta's origins. These features are north of the Ray Silvia impact basin, and it's these so-called troughs that have brought geologists to consider a new theory for the formation of the impact basins on Vesta. NASA visited Vesta in 2011 and 2012 with the Dawn spacecraft, which mapped the surface in far greater detail than what had been done prior with Hubble. And during that process, Dawn uncovered something truly puzzling about the asteroid. There were two channels running along the equator of the object. A trough here on Earth is defined as a channel used to convey liquid. The northern and equatorial troughs on Vesta are long channels that run along the equator of the asteroid, closer to its northern hemisphere. At the asteroid's middle lies Davilia Fossae, a trough that runs across more than half of the asteroid's surface, and Saturnalia Fossae lies in the northern hemisphere. What's interesting to me, at least, looking at these photos in this 3D map, is that they appear to be separated by a crater in the northern hemisphere. I'm not sure if that has anything to do with anything at all, but just thought I'd point it out. There are numerous theories for how these two features could have formed, but one suggests that each could be the result of a climactic impact. Christian Klimczak, a geologist at the University of Georgia and co-author on the new research revolving around Vesta, says, Vesta was on the way to becoming an Earth-like planet too, but planet formation stopped along the way there early in the history of the solar system. Therefore, studying Vesta helps us understand the very early days of our planetary neighborhood and how our own planet formed. Since Dawn's discovery of the two features, scientists have been puzzling over whether these new troughs could be related to two other iconic features on the asteroid, mainly Ray Silvia and Venenia. What's interesting, though, is that each trough appears to ring one of the impact basins, leading researchers to think that each impact created a trough. Christian Klimczak and his team wanted to investigate this in more detail using a tool that's commonly used in planetary science: Crater counting. This technique relies on the fact that crater impacts occur at random. Because older surfaces have more craters, a surface with fewer craters would indicate a younger body. Now, crater counting does not allow for accurate dating of surfaces, but it can be useful in determining if a geological feature is older than a nearby one. You see where we're going with this? I'm sure you've seen images of the moon or Mars that show craters overlapping each other. Well, this technique is used to determine the ages of overlapping features. It probably should be obvious that craters that form on top of others are usually younger than the ones that preceded them. But when the team actually got to counting, they found something truly odd. When Christian and his team counted Vesta's craters, something was off. Mainly, there simply wasn't enough information to allow them to determine if the Raysilvia and Venenia impact basins and the troughs were related to one another. Jupiter Chang, which is an awesome name, a doctoral candidate at the University of Georgia and co-author on the study, went on to say, "Our result shows that the troughs and basins have a similar number of the crater of various sizes, indicating they share a similar age. However, the uncertainties associated with the crater counts allow for the troughs to have formed well after the impacts. The abstract of the accompanying paper suggests that it is certainly possible that these formations are related, but that there is still quite a large margin for error here. The relationship between these features simply can't be determined, at least not through crater counting." However, it also notes that the Devalia Fossae and Raysilvia Basin overlap in their crater frequencies, which indicates that they can be considered to be of similar age or origin. Additionally, the Venenia Basin was determined to be older than Raysilvia, judging based on the fact that the Raysilvia Basin superposes the Venenia Basin. So there you have it. Vesta is more than likely a protoplanet left over from the early days of the solar system, and one that might have grown into a fully fledged planet if it hadn't been for Jupiter's gravitational influence. Vesta's craters are truly interesting and speak to a much more chaotic time in our solar system's history. And though it is small, cold, and desolate, it is a world filled with its own mysteries. Maybe someday we'll send humans to Vesta, and maybe they will answer these questions. Or maybe Vesta will hit the Earth and cause all this destruction. Holy crap, that's a lot of damage. But also, Vesta orbits out near Mars, so it's highly unlikely that its orbit would change drastically enough for it to hit the Earth. But I was certain that some of you with itchy comment fingers, you know who you are, were wondering, so there you go. If you dug this content, be sure to drop me a like and comment down below. And hey, if you dig asteroid videos, why not check out this other one on NASA's plan to smack one at super high velocity. It involves shooting meteorites with a giant freaking gun. And hey, that's pretty cool, right? Hey, check out all those wonderful names. Thank you, patrons. I'm Eric Malachite, and I'll see you next time.